Okay, here's another type of problem that we covered on exam 2. This is an electrical problem. We're looking at equivalent resistance between 2 points. Okay, so my thinking here is that when I ask for equivalent resistance, typically there's going to be some things that are in series and there's going to be some things that are in parallel. Okay, so your task is to identify what things are in series and what things are in parallel. And it could be that nothing is in series or parallel, but generally I wouldn't ask for the equivalent resistance in that case. All right, so I don't want you to leave you the impression that all circuits can be reduced using series and parallel combinations. Sometimes you get to where there's a circuit. Nothing else is in series, nothing else is in parallel. Okay, but that's neither here nor there. Let's move forward with solving this problem. Okay, so in this problem, I'm going to highlight what's in series. All right, so I'm looking at this and I think, well, it's the same current, the same actual electrons are going between the 300 ohm resistor and the 372 ohm resistor. It's the same electrons, therefore the 300 and the 372 are in series. Okay, so I can take this step at a time, only change the things that have changed. Okay, so I can combine those, and I know 300 plus 372 is 672. And then I would have 504, and 112, and 100. Okay, so next. The next thing I'm looking for is it the same voltage across? Well, I know this is in parallel, I can tell. All right, so the way I verify that is this the same voltage, right? There's only a wire here at the top, so there's no voltage drop. So this, if you wrote a loop, this voltage V1 would be equal to this voltage V1. So we're on this loop, V1 is equal to V1. It's the same voltage, all right? So if it's the same voltage, that means 504 and 672 are in parallel. Okay, so you can write that down that 502 is in parallel with 672. That's the notation we often use for parallel resistance. And then that calculation is 502 times 672 divided by 502 plus 672. Okay, and I calculated that down here. Oh, I guess I didn't. All right, so let me just tell you what that answer is. That turns out to be 288 ohms. Okay, so the next thing we do is we write down the equivalent circuit that we have. So I've only looked at the parallel combination here. So I replace that with 288, and I have these resistances left. Okay, and so then I ask myself the question, well, what's next? Is anything in parallel? Is anything in series? And I see here's the same current flowing through these. All right. If there were current flowing, it would be the same current flowing through these. Okay, so those are in series, and so I add those up, and I can tell that the equivalent resistance would be the sum of these. So 112 plus 288 is 400 plus 100. This gives me 500 ohms. Okay, so that's the thought process I want you to work through. It's helpful if you go ahead and put extra sketches in. That way I can give partial credit if you get something right. If I just see the wrong answer, it's hard to give partial credit. So make sure you take it step by step and explain what you're doing. It helps the odds of you getting it right, and it helps me with the grading.